Hey guys, I'm going to walk you through a new tool that I think is really good. It's called Causal, causal.app.com. And what it allows you to do is modeling, right? So just to kind of show you a basic example that I think I could apply really to any client. This is a model of the funnel. So we have, you can kind of build these the way you want, but like I have an input of cost, we have the CPC, this conversion rate, and then it works out the clicks, works out marginal cost. I'll explain what that means in a second, and then works out the conversions, which is just clicks times conversion rate, and then that gives you the CPA. Right. So what does this? What makes this better than Excel or Google Sheets? So first thing is that this is a probabilistic model. What does that mean? It means that you can give it a range. So here I typed in 1 to 2, meaning my CPC is going to be between $1 and $2, and it actually generates a probability distribution here of if you say that your conversion rate or your click-through rate is going to be, or CPC is going to be between $1 and $2, what does that actually mean? So it means that the average is going to be $1.50, but there's going to be a whole load of other potential values or with different likelihoods. And when you stitch a few probabilistic ranges together, so like here's one for conversion rate, then what happens is you get a conversion number that's on a range as well. So what you can see here is that what are the potential outcomes for conversions, given that there's some uncertainty of the model. So if we just had 4% and $1.50 like in an Excel sheet, then it would give you an exact answer. But that's actually really bad to give to a client, because if you give a precise answer, they expect you to hit exactly that goal. What this allows you to do is really educate them that there is uncertainty involved. And obviously, the more uncertainty, less uncertainty changes the model here. So if I change this, for example, say if actually the conversion rate was between 4 and 5%, then that changes, makes it less variable, and also kind of changes the outcomes as well. So I can change that back. Cool. So that's one thing. Same thing with CPA as well. So you can see here that you have the CPA distribution. Another thing to point out actually on these distributions, it actually gives you the probability for each point. So you can, for example, say, there's a 95% chance that I'm going to get at least 100 conversions. So great, that's my lower bound when I tell the client, we're going to pretty much at least get 100 conversions. I'm very, very confident in that. I'm 95% confident, right? Like you actually give them a percentage. It shows you, where that average range is. This is right in the middle of the distribution, but you can see 136 is the average that they've given you, and the reason why is it's kind of skewed to the right. So there's a very small chance that you're going to get actually like 200 conversions or 215 conversions. So if the client's goal is 170, you can actually now feed back to them and say, there's only an 8% chance we're going to get 170 unless something is wrong with our model, in which case let's revisit these assumptions. So this becomes an education piece. It becomes a negotiation. It becomes a meeting of minds, right? Like we can actually make these estimates better, these assumptions better, through talking to the client, and modeling out. Okay, well, we didn't take into account this, right? So that's very, very cool. The other thing that's cool, actually, I'm not showing you here, but you can actually import data as well. So like you can actually just import like a Google Sheet attached to data source, and then that's actually going to give you the distribution. So I don't have that here, but it's going to give you like a proper distribution of then like what is the actual range for clicks. Like if you import the clicks, for example. So you can kind of imagine connecting this up to your funnel IO account, and then actually kind of doing some forecasts based on that. And the forecasts actually are really cool too. So first thing is this scenario thing. So here's the scenario I made earlier. If the CPC improves by 20%, so if it gets 20% cheaper, what would that do to the model? You can also so you can kind of go back there and you can say, okay, well, I'm going to get 136 conversions, but in this scenario, I'll get 170, and it's moved that whole range up, right? So if I improve the CPC, then the conversions is going up by a fair amount as well. You can also create new scenarios. So I'm going to say cost halved, right? So if they're like, well, that's way too expensive, so we're going to cut the costs, and like, what happens if we just spent 2,500? Cool. So then it's giving you the scenario at 2,500, and just to make this kind of interesting, I actually baked in an efficient frontier here. Like if you do an efficient frontier analysis, what it gives you is it tells you how much the CPA goes up by for every X amount of spend. Or how much increase in spend leads to an increase of $1 in CPA, and in the scenario I ran this for, it was like every extra $163 that was spent led to a $1 increase in CPA. So what I did is I kind of took out a minimum cost. So I said, anything above $1,000, divide the spend by 163. What that means is if I spend $1,000, the marginal cost would be 0, right? So I just get the normal CPA. If I double that, say spend $2,000, then I'm adding an extra $6 onto my CPA to account for the fact that spend is less efficient at scale. If I spend $10,000, then it adds quite a lot to that. Right? So $55, so almost half of the CPA is made up from the fact that there's a high marginal cost. And that affects the number of conversions that we get. So this is a really, really cool way to bake in your efficient frontier analysis too. So I'm just going to change that back to scenario cost halved, right? So now you can kind of compare these and you say, okay, well, one way we can improve performance, we get 170 conversions if we improve CPC by 20%. But actually, if we halve the costs, then we're going to get 68 conversions versus 136. Final thing that's cool is sensitivity analysis. So it actually tells you based on, so this is, based on the CPC, CVR, these are the two ranges. So they're the ones with variance. It tells you how much variance these contribute to the model. So meaning 63% of the change in number of conversions is coming from the CPC metric that you put in. And that's because there's a relatively wide range. Also how important the CPC is to the overall model. Right. So now you could go back to the client and incorporate this into the strategy and say, actually, because the CPC is so variable, if we just improve CPC, like that's going to have a bigger impact than if we improve conversion rate. Conversion rate is pretty solid, right? It's pretty straight. It's going, it's like, it's not making that much contribution to the model. So let's focus on improving CPC through, say, creative testing instead. Cool. So that's really, really good. You can export to Excel, everything like that, right? Now I'm going to show you another model. So I made a couple of others based on models that we've made at Ladder. So one is test duration. So how many tests can you run? So same thing here. This is basically the same as the VWO test, except much more interesting because now we can put a range of expected increase. So I don't know if my test is going to have a 20% impact. Maybe it only has a 10% impact. Maybe it has a 30% impact. Who knows? But now I can just put that range at 0.1 to 0.3. It works out the distribution between them, and then it's going to tell me I'm going to need, on average, 22 days to conclude 12 tests. It's working out the observations per variation in the same way that we've done it in Excel models in the past, and then total observations needed. So I can change, okay, well, I'm not going to do 12 tests, I'm going to do 10, right? And now it gives me the distribution. And what this is showing you here is the probability of how many days it's going to take to run the test. So that's meaning, like you have, say here, so the inverse of this would be 80%, right? So what this is saying, there's only a 20% chance that it's going to take more than 25 days to run those tests. So I'm pretty happy with that. So it means that there's an 80% chance I'm going to be able to get 10 tests live, and then they're going to conclude, by the end of the month. So very, very cool. And recommend you guys play around with this. And actually, one great thing you can do here is you can invite someone to view, to admin, to edit, just like a Google Doc, and then you can also make it here. So like anyone with a link can view, and then you can copy that. You can also embed it in the website. So that's pretty interesting, and we're going to experiment with that on our blog. Cool. So final one is growth calculator. Now this is just like the growth calculators on the website. Maybe we'll replace it one day. Who knows? But it's much more powerful because you can give ranges. So on average, you're going to be targeting. So like some of your tests, you're going to be impacting 5% of the business. So maybe it's a small niche audience, and sometimes you might be impacting as much as 20% of the business. So you can kind of make those decisions, and you can say on average, business scope is contributing. It's going to do on average 13% of the tests of the business with your tests. Now, metric impact range 20 to 40%. That's when you get a success. What's the impact? And then success rate. So these are the same metrics you see in the growth calculator. You have the growth goal, duration. So duration is a little bit different, which is quite interesting. So you choose a start date, and then an end date as in terms of months, right? So if I wanted to do this through June, then save, confirm. Here we go. So now we're growing 50% over 6 months, and it's telling me I need to 3 tests to win every month, and that means I need to run 6 total tests. Cool. So a couple of things that are interesting in this model that I added. So one is so first it tells you the monthly growth goal. So 50% growth over 6 months is 7% a month, and then I've baked in this baseline growth. So you could set this as 0, and if you do, it'll should work okay. Yeah, so that would mean that the business is not going to grow without Ladder's help. That's a strong assumption to make, right? But in some cases it's true. You could even, I think maybe this would work with a decline. So let's do minus 0.2. So the business was going to decline 20% or 10% without Ladder's help, and now we need to make up for that with 17% growth, right? Makes sense. And then it's going to I'll set this back up to say it's going to grow 2%. So, yeah, here we go. 0.2. There we go. That makes more sense. Cool. So that's how much they're going to grow without Ladder, and therefore we need to make up the difference, which is 5%. Now that means 1.5 wins are needed per month. So one and a half of your tests need to succeed, but it's actually a range. So you can see it's actually quite a range. So in some extreme cases, you might need to have 3 tests to win. If those tests end up to be being relatively small. It also calculates total wins. So this is a hint at the cumulative function. So here it's kind of weird the way it looks, but essentially it starts with wins needed, which is that metric here, and then it's adding up over. So this is t-1 over the time period. So basically, it's like a cumulative. So it's adding up for every time period, which is duration 6 months. It's adding up the wins needed. So it's basically giving you how many total wins we need, and then we have tests needed per month, and then total tests. Cool. So that that's giving you some really interesting information. I think that like this probability distribution is like one of the really key things I think about the tool. Showing the client that we're probably going to need, we're almost definitely going to need to run say 9, 10 tests, right? Or 15 total tests it was saying here. But like, you can choose your comfort level. So yeah, if we run 8 tests, we're probably only going to be 32% likely to hit the goal, right? So, or sorry, 60% likely to hit the goal, 70% likely to hit the goal. So like this, I understand you guys might not have that much experience with modeling like this. It's called a Monte Carlo simulation. It's super interesting. There's a lot more, I think, stuff coming on the roadmap from these guys, and it's already pretty powerful as it is. But yeah, test it out with your clients. You can sign up at causal. Causal.app.com, or actually just shoot me an email if, and I'll just intro you to the founder. I think might be easier. We're also thinking about setting up like a Slack group with them, so that they can give us some feedback on the tool. Or we can give them some feedback, and then they can give us some support if we're trying to build something. So just to give you guys kind of a general understanding, like these 3 things. So the funnel model maybe took about 5 minutes to build. It's super quick. You can duplicate them once you built them. And then test duration took a little bit longer because I had to figure out the formula. Growth calculator was like 5 minutes as well. You can also look at some of the things they have. So here's like probability of a project being completed on time. So like, you can do a lot of interesting stuff. Discounted cash flow. This is one for Yanis. Here we go. And you can kind of see the general kind of distributions of stuff, and even build in tables as well, which is quite cool. All right. Hope this was useful, guys. Check it out, and let me know how you get on.